Okay, so here's the last lesson on combining functions. And it's about something called composition of functions. So let's look at what that looks like. So the radius of an oil spill is increasing at a rate of 2 kilometers per day. How quickly is the area of the spill increasing? Well, let D represent the number of days. Let R represent the number of kilometers the radius is after D days. And then finally let A represent the area with radius R after D days. So you see how area is going to be a function of the radius, but the radius is a function of the number of days. So we know that the area is pi r squared. We also know that the radius is 2 days, is 2 times the number of days, right? Because it's 2 kilometers per day. So that means that we can combine the area and the radius to be pi times 2d squared, because this represents r, because the radius is 2 kilometers per day. And now we can simplify that. So pi times 4d squared, which means 4 pi d squared. So that means that the area is equal to 4 times pi times the number of days squared. So you see how if we can combine functions, we can skip middle variables. That's the whole idea. Here we had area with regards to radius. Here we had radius with regards to days. Well, combining these two, we had area with regards to days. So A of D, which we didn't have before. We had A of R and we had R of D. Now we have A of D. All right, so let's say how we do that mathematically. So two functions f and g can be combined using a process called composition, which is represented by this, which says f of g of x. It can be written like that, and it can be written like this, which again is written by f of g of x. So when f is composed with g, what we do is we take the output of g and use it as the input of f, right? So f of g, right, means first we take g of x is equal to something, and then we take this something and we plug it in to f, okay? So it's like doing a function twice. So let's look at the first example. So f of x is 6x minus 1, and g of x is x squared minus 1. So f of g. So f of g means f of x. So what we're going to do is we're going to take this g, right, because that's g, and we're going to plug it inside of f. And f is 6x minus 1. So we're going to take 6 of these things, and we're going to subtract 1. So 6x squared minus 1 minus 1. So this is the inside function, g, and this is the outside function, f. Okay? And then we can expand and simplify and get 6x squared minus 7. Okay? So let's look at the other way around, g of f. So the inside function now is 6x minus 1, and the outside function is this squared minus 1. So that means we have 36x squared minus 12x plus 1. That's just taking this and squaring it. And then minus 1, that's that minus 1. And now we simplify and we get 36x squared minus 12x. Okay? So all we're doing is we're taking an inside function, plugging it in, and outside function, then we simplify. So here, f of g, right, means g is the inside function. So 4x squared is the inside function. And the outside function is the square root. So we're going to take the square root of 4x squared, and we can simplify that to 2x. G of f, on the other hand, the inside function is square root, and the outside function is 4x squared. So it'll be 4 root x squared, which simplifies to 4x. Okay? With lists like this, it becomes a little bit different. But again, this means f of g at 4. Well, g at 4 is right here. G at 4 is 1, so that's what we plugged in. And f at 1 is 5, so that's what we got there. So g took 4 and turned it into 1, and then f took that 1 and turned it into a 5, right? The second one, g of f at negative 2, well, f at negative 2 is 0, so this is like saying g at 0, and g takes 0 and makes it into a negative 1, so that means the answer is negative 1. So f turned negative 2 into 0, and then g took that 0 and turned it into negative 1. So that's what a composition of functions is. So does f of g equal to g of f? Answer is no, and you can look at the last slide for examples. So here what I'd like to do is first, I'd like to determine what f inverse looks like. So if f is 3x minus 1, f inverse, and I'd like you to change this on your sheet if you printed it, but f inverse, remember we switch the x and the y, and then we isolate y. So we add 1 to both sides, divide both sides by 3, and then we just turn this into f inverse, and that's what the inverse is, x plus 1 over 3. So here we want to do a little bit of composition. So f of f inverse. So that means the inside function is f inverse, which is here, and the outside function is 3 times that minus 1, so 3x minus 1. And now let's simplify and see where that gets us. So the 3's cancel out and we get x plus 1 minus 1, which is x. On the other hand, we're going to do f inverse of f. So f is on the inside, f inverse is on the outside. Still similar, we took this and we have this plus 1 over 3 because it's x plus 1 over 3. And we simplify again, 3x over 3, that simplifies to x. So what that shows us is that f inverse of f is equal to x, and f of s inverse is equal to x. So that should really make us happy, because if we do a function and then its inverse, nothing happens, which is what we've been talking about with sine and sine inverse, and log and exponential, and all those types of functions. All right, let's look at a graph. F at g at 0. So first, let's find g at 0. So first, let's define the red one as g of x and the blue one as f of x. So g at 0 is 1, because when x is 0, y is 1 right there. So f at 1, because g at 0 is 1, we're actually looking at f at g at 0, which means we're looking for f at 1. So that's 0. G at negative 1 is 0, so f at 0 is 1. F at 3 is negative 2, and g at negative 2 actually doesn't exist, because the function g only starts at negative 1. So it's okay for compositions to not exist. All right. For this, the domain of f is all real numbers. The domain of g is bigger than or equal to 0, because we have a square root function in there. The domain of f of g, so f of g looks like this, right? Now, even if we expand this and simplify, still we cannot put in anything less than 0 into x, because there's a root x there. So the domain is bigger than or equal to 0. G of f, on the other hand, we have the square root of 2x squared minus 4. Well, here the domain is all real numbers, and the reason is because that 2x squared is always positive, so we can always take a square root of it. Okay? So it's important to understand the domain, the way that the domain changes with composition. Okay? And that's all.